Welcome to Maintaining the G7 Print Condition. Today we're going to talk about how to use measurement and process control to maintain your G7 print condition. Welcome. Today we're going to talk about how to maintain a G7 print condition. We've just been introduced by Ellis and Wachob. My name is Ron Ellis, and I'll be one of your speakers today. And we also have Jim Wachob from the HardingPoorman group. Jim will be great. He's a real-life user, going to give real hands-on experience. We'll move right now and talk about our agenda. Today, what we're going to cover first is how to maintain a G7 print condition. We're going to go through actual real-life measurements. I'm going to pull out a press sheet. I'll measure it, and you'll see how we analyze and look at a press sheet and see if it's matching the G7 print condition. After example measurements, we're going to have Jim from HardingPoorman group speak. And Jim, as I said, is a great user because he uses this every day, and he's going to talk about how they run up to a make-ready, how they troubleshoot a job when it's not matching. They're a perfect example of somebody using process control correctly, and they use it. After that, there's an opportunity for a question and answer. Before we start, we're going to talk a little bit about manufacturing and talk about the way printing today and the way that printing works. The recession is very difficult for printers, and in the Boston area where TeshCon is based and also where I'm based as a consultant, alone we lost over 100 printers during the 2 years of the recession. And less than 15% of these printers had scanners on the press, or 11 printers. So talking about it is important because it relates to how efficient people are. As we went through the list of who went out of business, we would basically look at, did they have scanners, were they G7, how modern was their equipment, and they were not efficient. So the one good thing that did come out of the recession is that the printers still around here are leaner and much more efficient than ever. And I've seen this firsthand. Recently I was traveling through Asia, and printers are running like we did 10 years ago. They don't have on most of the presses, much more waste. And the different economy, it's a little different, so they can afford to waste more. They even have hand scanning on their Epson proofs, so they'll use one by hand, whereas pretty much every printer in the U.S. that buys a new Epson now is buying an auto scanner so that every single proof is QC'd and checked. So in the U.S., completely different. And one great thing about U.S. printing right now is that those who remain are very efficient. Successful printers right now, everything is automated. And the most successful realize that with tight margins, the only way to become more profitable is to be more efficient. So we reduce our manufacturing costs, and one way to do that is to reduce the time it takes us to get to color. And the second part of that is to remain repeatable so that we don't get back into being inefficient. Printing a controlled process, and that means that printing is manufacturing. So we're getting away from craft and moving it towards manufacturing, which means we have to know what we're doing all the time and be very good at it. The great thing about G7 is the target. So the print condition is the target used by most of the printers in the U.S., as well as most of the printers in Asia and Latin America. G7 is a great thing for U.S. print because it is suddenly given our printers targets to aim at. For G7, most printers use their press as a target. They take a press in the press room, they'd run a sheet, they'd record passes off it, they'd match the proofer to that press. And that's a problem because the press is the least stable part of the print workflow. It's a situation in which we look at the press and the press just, it's unable to hold. It's mechanical, it's varying, it's moving all the time. Even brand new presses, day after day, are changing. So without having a target, it's impossible to tell how good you're doing. And so many printers in this previous scenario had a target. They actually could not tell day to day where they were. And if you don't, you just don't know how you're printing, and you have to have something to measure. If you're measuring, you have to have something to compare those measurements to. basically, if you don't know how you're printing, if you don't know what color your ink is, what your dot gain is, what color the print is, you're printing to chaos. The thing about G7, it gave a universal target. We can hit it with proofers, we can hit it with digital printers, we can hit it with offset presses. And we can tell if we're hitting it. We have something to measure against. So one that happens, and one thing that we found as people began doing G7 calibrations, is that it's fairly easy to do that calibration. It's nice calibration, it's fast, it's quick. If we set it's a target, you can tell if you've achieved it. To the topic of G7 calibration, the thing is the G7 calibration part of it is a procedure, and it's used to line up the press to the G7 aims that we're going for. But the calibration is not a one-time procedure because the press is constantly changing, and so we'll drift away from it. It's a matter of time. Many people doing G7 calibrate the press to it, they mail a sheet to get qualified, and then they don't watch that calibration. And being the most variable part of the press, if you think about it, we have blanket rollers, chemistry, all those change every day, so it is inevitable. And the repeatable print condition is measure and then correct when we deviate. So G7 is a great calibration method. It's also an aim. To calibrate and to not constantly monitor how you're doing against that aim is to kind of miss some of the big value that G7 brings to us. So the next thing, as I mentioned, it's important to measure, and that brings us to the importance of measurements. If you're not measuring, how do you know if you're out of calibration? That's the kind of thing. If you're not measuring, you have a way of knowing if you're actually achieving your target. So it's going to tell us if the conditions have changed, and by measuring, predict if we'll be able to match a proof. Pretty much, if on press, the things that you're going to see us measuring in the next few screens, if we're measuring on press and unable to achieve those, if we're not hitting those numbers the way we should, we're not going to match a proof. If we match a proof, we're not going to make our make ready, and we're throwing money away. So if we do this measurement, we can tell if the press is still profitable. We need queries to be efficient and to stay in business. We need disasters where suddenly we can't match a proof and a customer comes in and they're not happy and we look like idiots. So everything about this business today pertains to getting up to color quickly and printing. And that's where money is. And I'll say it again, but as Peter Drucker said, what's measured gets managed. If you're not measuring, you're not doing yourself any favors. That's how we tell if we're hitting our targets. We tell if our make-readies are going to be achievable. It's how we tell if we're doing good printing. Now, G7, it's great to have a target, but the metrics for G7, the way that we do things with G7, are completely different than traditional press metrics. So key G metrics that we look at are based on LAB color, G7 based on color, and it's based on the color of the gray, other than the traditional print attributes that we use to light density and dot gain. It's very, and if you, one thing that I tell my customers is that if you'd like to be in this industry in 5 years from now, if you'd like to be in 10 years from now when I'm working with people, here that you learn LAB color. It's essential because the people who understand how to measure and QC LAB color are the people who are employed. In markets in the U.S. print industry, which are things like packaging and non-traditional printing, every of these markets is based on this. So when I deal with major brands, with major customers, they're actually QCing and accepting jobs in many cases based on delta E comparison of LAB colors. So one thing worth learning is how to understand lab color. I don't have every press operator to learn this, so but who don't, we'll translate it into their local process control aims, which means density and dot gain. There's got to be someone in that plant when a job isn't hitting make ready who understands LAB to troubleshoot it. You're going to see it in the next few screens. So as I go through and I look at this press sheet, you see how we use LAB and how we use tools that can interpret LAB like the SpectroDens to see where we are and what's going on. In G7, there are two compliance levels that are really common and really important. There's actually 4, but we're only going to talk about 2 of them here. So before we go any further, we're going to cover sure you understand it. There's types of G7 calibrations that are very common on press. It's called G7 gray, and G gray is only a calibration to gray and to tonality. So this means with G7 gray, we primarily care about gray. And tone curve for the CMY is correct, and then the balance being correct. Those are the 2 components. We want to make sure it's gray. We want to make sure that the curve is the right weight up and down it. The second one is G7 targeted. G targeted is also concerned with gray and tonality, but it's also concerned with the color space. With G7 gray, we're going to be looking at many more things. That means we require the solids to be a certain color, the overprints to be a certain color, to match our aims. In doing this, it's a much more accurate color match, especially in the hard colors. So if I walk into a printing plant and people tell me they're having trouble matching the purple on the proof, maybe the bright reds, the maroons, the sky, that's the overprint. And if those colors, those overprints aren't correct, then I know they're not going to match the proof. So looking at more when we're doing targeted, and pretty much if you're an offset printer matching GRACOL, you're G7 targeted. So G7 gray tends to be things like flexo, screen print, things where they can't achieve the color space. So it's going to give them a match in the midtones. It's going to be neutral. It's going to be gray. You could even hold it up against a GRACOL proof, and pretty much except for those overprints and other areas, it's going to look like a match. But really being precise, which would be offset, we're going to do G7 targeted, and that's how we're going to match it. These key G7 metrics that we're going to talk about, the front, and you can see it on the screen here, is NPDC. That's in the upper right-hand corner. And you can see the CMY curve, the NPDC black curve as well. These are the weight, so these are the tone weight. Now the CMY is combined, so all 3 of those together, we measure the gray. It could be that tone value. That's delta L, and also corresponds to the L star of LAB. The second thing we have is gray, and gray is delta F or delta CH. And if you see gray, which is the bottom graphic, we want to make sure that we're neutral, that we're not casting off in one direction. It's the AB of LAB that we're using to look at that. So these tricks are very, very important, and we're going to measure them. It is G7 gray. We're gray, we have the right weight. Pretty much any CMYK device we can use this with. It could be digital printer, could be flexo, could be gravure, could be screen printing, could be wide format, could be offset. It works anything that's CMYK. So for this, the key fundamentals that we look for. And the important thing to note, you notice it on the little graphic in the middle, it says max density. And G7 scales to the paper color and the ink color, the maximum neutral density. As we change our print method, as we change our substrate, G7 actually takes that into account and moves with it and scales it. Now, doing G7 targeted, we have other metrics, and these metrics become important, as I talked about. And that's the color of the ink, and that's the color of the overprints. And pretty because, as I mentioned, this is assuring that our ink is the right color and that our prints are the right color. And as we do process control, this helps us to see if an ink has changed or if anything changed. So very, very important. Now look here of the things that we're checking on a sheet fed press usually. Look at it, we're back to targeted stuff, NPD, we're going to check delta F. And then if you go over on the right, you can see CMYK. Over to that, past density. And density is not color, it's ink film thickness. But past density, you can see we have delta E. So we have two values which for GRACOL are based on ISO. This is basically what color the ink should be, what color the overprint should be. And if you look at those, that delta E, which is a deviation between two numbers, is how far apart it is. Now I want to be less than 5 for my solids, and for me I like to be less than 5 for my overprints. And GRACOL does have requirements. We want to have, if you're GRACOL G7 targeted to GRACOL, we want you to have your in your overprints within a certain set of numbers. So these are important when we line up a press, and then we go out and actually see what's wrong with the job. These are some of the things we're going to look at. So if I was reading the gray patch, which is a 50-40-40 patch in GRACOL, what I should be seeing is the being 57, the A being 0, and the B being -1. That's depending on paper color, but if I'm looking at the GRACOL data set, that's exactly where it should be. I want my solids to be 5 delta E or less against those lab values that are below, and my overprints to be 5 delta E or less against the lab values that are below. So looking at it, just a quick example, it gives us an idea of where we want to be. And in a minute, we're going to start looking at numbers and telling if we're actually matching and how we're going to troubleshoot this question. First, a quick example that will give you an idea of how I would go and look at a press sheet and see if it's correct. With this, I'm going to take a press sheet that I have here, and it was targeted to GRACOL, and it's a real sheet from a job that I did last week. Give you a quick idea of how I look at this press sheet to see if it's in G7 compliance. So the thing that I'm going to check is pretty much always check that first. You can also tell if the G7 print is going to be correct, choosing that one patch, the 50-40-40. For more, as I fine-tune check, I look at the highlight patch, the 25-19-19 in the shadow, because I want to be neutral all the way up and down it. General for printing, if I read that 50-40-40, not neutral, then I know I'm in trouble. So as with this first patch, we can tell a few things here. And keep the SpectroDens that you see here automatically calculates against the paper color. That means it's going to compensate for the paper color and change the value that our target is automatically. That it shows me visual things and tells me many things, and I'm going to show you a close-up of the screen. Everything we're looking at here, I'll also tell you how you'd see it on a different device if it didn't have a screen like this, because well, SpectroDens makes it easier. The theory is still pretty much the same, no matter what device we're on. So first thing here, I'm going to look over to the left-hand side, and use a little word that says HR, so I can see how my NPDC curve is. And this is showing me that I'm very close, but I'm a little bit too light. So it says -3. That means I add a little bit of density, so it says HR -3. That's effectively the L value. So showing me what my L value is, and that's my curve. So my HR is a little bit light, and now that you can see my gray balance. That's the A and the B. The A is the green to red, and the B is the blue to yellow. If I look at that, it should be 0, 0, and the A being +1.2 means that I'm a little bit too red. B being +3 means I'm a little bit, well, more than a little bit too yellow. I'm pretty yellow. And then if I look at it, you know, I can look above it, and I can see what the SpectroDens recommends. So the SpectroDens recommends that I add 4 points of cyan, 2 points of magenta, where it is. That's my weight up, and that should, by more cyan, that should get rid of my little bit of pinkness that I'm seeing there. And it also should take care of the yellow cast that we're seeing here. Now, you all in your head, if you had a different instrument, you'd read this, and it would say that you're, you know, something like 59 or 61 +3, and then in your head you have to actually calculate and say, oh, I'm too red, I'm too, translate that to the press. But with the SpectroDens, it gives you the numbers right here. But the main idea, look at the color numbers. These lab numbers are telling us that we're a little bit too pink and we're too yellow. SpectroDens gives us a little recommendation on how to get there. So this is called guide mode, and gray guide mode, and gray guide mode is going to give us some other things that we can look at as well. Look at as I click on the black 50 patch. That's my NPDC for the black. And I look at that same thing. I'm a little bit too light, so I'm going to add a couple of points there. So we add a little bit there and make sure that we get that back where it needs. In this function called gray guide, it shows many things. If I click on a gray, it shows me gray balance. If I click solid, it's going to show me where that solid is. So the first thing I'm going to do is click on my cyan solid and see where my cyan ink is. And here, what you see at the top is it says cyan. It shows me the density so the pressman can see where it is. And right below that, delta E 2.3. That's compared to the reference values for GRACOL or for ISO you see at the bottom, which are the same reference values. And I look at it and see that cyan is correct. My cyan ink is where it should be. I have a check mark. I don't have to worry. The ink hasn't changed. Right where I should be on here. And the lab values are on the bottom if you wanted to reference it. Check is my magenta. Same thing here. I look at it. I've got a density of 148. Delta E is 3.18. I'm under my 5 delta. So I'm in good shape here, and I have a check mark. So good, uneventful at this point. Next time, now I'm at yellow, and yellow showing me 1.6, and it's giving me LT of 5.6. So that's not good. That's failing, and that's a problem. And it relates to what we saw in the gray balance because the gray balance said we were too yellow as well. So I look at it, I see it fails, and if I want to do a little more research, I'm going to switch my SpectroDens to a mode called ISO check. ISO check mode. And when you look at ISO check mode, I click around on a few other pieces of the sheet. And by click around, I can see that most of my patches are actually more around 7 or 8 delta E away. That's pretty far away. So I click on it, I read it, and you can see here, not only does it tell me the delta E, but it gives me a recommendation of where to put it. So if I click on that, I look at yellow, you see a little minus that's highlighted, and it says minus 1.3. That means if I drop this ink 13 points, it predicts that I'll get to a delta E of 2.1. So I'm going to do that. I'm going to actually drop that down to 13 points on press, and I should be able to pull that down to where that yellow is passing. Now, if I didn't have a SpectroDens, if I had a traditional spectrodensitometer, I'd read the lab number, I'd look at the reference chart, and then I'd calculate it in my head. You know, I need to reduce yellow. Not so you've done it a bunch of times, but it helps to have a device that does it for you, especially if you have many people using it. It's not everybody does math and thinks the same way. So what I do after I've checked these, I've seen my yellow is out. I want to glance at my overprints and see what's going on there. At the bottom, these are the target LAB numbers. See in the SpectroDens window, in addition to a delta E, it's showing me the value that I have there. If you look here, you can see the CY overprint has a B star 30. If I look at my gift for that CY overprint, it's 25 is the B. That's showing me too yellow. So by looking at that, I can check. I can see that overprint is too yellow. When I bring down my yellow, that's probably going to bring my overprint to where it will pass. So important to see. So like that. The second thing to check is the other overprint. I go to the MY. I can see MY is passing, but I want to make sure I reduce my yellow that I'm not going to mess up my MY overprint. So I look, and that 39 is a little bit high. I have a little bit of room to move the yellow down there, and so I'm not going to hurt print too much by moving it down, moving yellow down. And then I look again, there's no yellow involved here. This is a good overprint. And when I print, if I move, it's not going to affect this at all. So quickly saying what I need here. This one. Okay, so there's a few things that happen here. But based on this quick read of this spreadsheet, what I see here is that based measurements, I need to pull down the yellow to get gray balance and to improve. And when I pull down yellow, in addition to getting gray, I'm going to pull my yellow into an ISO pass. And especially, more importantly, fix my overprint so that my color mix is correct. So quick, you can see with that couple of reads there, we can see what's wrong with the spreadsheet and what's going on with it. The other thing that I normally would do when I achieve a G7 calibration is I add your dot gain against my reference benchmark. I ran that in here too as well. But I could see, if done that, I would see that my dot gain for yellow is a little higher than normal. And often additional metrics like dot gain and density confirm what we see when checking the G7 metrics. So when compared to the benchmark value for that press, it's important to notice that we can happen. Now there's two situations too that this becomes valuable. And one would be I went back to a trap that wasn't matching. So if my yellow was saying it was 7 delta E out and I was a fairly low density, I could actually look at the lab values there and detect that maybe I'm contaminated. I'm picking up cyan or another color. And I'd be able to see that. So quickly on that check, if I was failing a solid, maybe it's because my density is too high. Maybe it's because something's wrong with the ink. So I can set up and see changes in the ink when I'm measuring for that. It's important. And then often color aims will help you make up for things like your change in paper color. Because I use the final values you're looking at. If you're on a yellower or bluer paper, you're going to have to move your density up or down to actually make that color be right. So it's going to help you and guide you with that a little bit. Here I have the SpectroDens in the famous arm attach mode. So I'm joking with my customers a few times that I use this thing so much, and it's pretty quick. It's good for teaching people and gives you quick results, as you saw there, that I feel like if I don't have it on my arm attached to me, when I go in, that I'm naked. And I have a lot of times people will say, we just want to use our equipment, but I can do it a lot faster when I have this. So example of the last week I was on a web press run. Web press run, if you turn it on, it's like a jet engine flying through there. And SpectroDens, I was able to nail all the overprints and get quick information to the press operator that if we had to sit there and scribble on a pad of paper and look back and forth at a reference chart, would have been a lot slower. So pretty good. So I feel like without it, I am at a disadvantage in the press room. It's a pretty big part of my toolkit. I wanted to talk a little bit about automation, and because everything that you saw me doing right there, that was clicking by hand measuring a press sheet. And it's possible to automate things. And that means that every single press sheet that gets pulled out gets scanned. So that type of automation means on the screen, instead of click when there's a problem like I was doing there, you're doing it live. As you're running through the job, you're scanning the sheets, you're getting instant feedback on what's going on. You're seeing fills on the traps, the solids, you're comparing the dot gain, you're seeing everything. So in the world of modern printing, automation is essential. Much better after the recession because many people picked up presses from companies that went out of business, and there's a lot of good used equipment that had scanners. It's pretty infrequent these days that I go to somebody who doesn't have a scanner. But if you don't scanner, it's critical. So automation, ink presetting, and then which I'll talk about in a minute. As I mentioned before, that's Peter Drucker up in the corner, the famous efficient consultant. And what he said, what gets measured gets managed. Keep that in mind. If you're not measuring it, you're not going to know where you are, and you're not going to know what type of condition you're in. Quick shot here of the Teshcon devices that they have. SpectroJet is a very inexpensive detachable one that you push across the sheet and reads the color bar in just a few seconds. Can be detached for packaging applications where you can read spot colors. And then below that, the SpectroDrive, which is fast and fully automated. And that's their kind of big, top of the line scanner. So then we get a question of how do you check the print condition? Now, the press is very mechanical, so presses are changing all the time. So to maintain a print condition, we really want to benchmark everything. As we do G7 calibration, we want to make sure that we notate everything: blankets, roller stripes, pressure, ink, ping, and we want to have that all written down. Then if we suddenly notice that we can't match color, typical thing might be the cyan suddenly is printing at 5%. When we calibrated, it was printing at 16%. In this, we noticed that was the cyan unit. We tell the pressman to check blankets, roller, pressure, packing, and look at the color measurements and see if there's some paper issues or something else going on here. If we get that, by having the pressman find it on the press, and presses are always moving and changing, so most of the time this is what fixes it. But if we can correct that way and with some small solid ink density adjustments, we can fix it. If it's such an adjustment though, then we're going to lose wrap. So if we move our density up or down too much, we're going to change our ink film thickness, our overprints, and the actual color of the ink. If we do that, we might have to get through a job, but if that happens on job after job, that means that our maze aren't going to be good. We're not going to be matching proofs. So if it's nothing that can be mechanically fixed on the press, and this could be major maintenance, you actually change the physical condition of the press. For some people, it's environmental, which means during certain times of the year, they can't control it. But if that happens, then at that point, you do a curve correction. So you'd redo the G7 calibration. So very important. Most people, they calibrate once, and they calibrate. They'll be good for a year or maybe less than a year, but they're usually good for quite a while. And then they're watching it and just moving the press back and keeping the press condition, using it as kind of a dashboard for the press. So pretty important. Second thing is we want to make sure that we're watching. We want to make sure that we see when the press moves out of calibration. We have a customer coming in and be unable to match their proof. And the other thing is that when you calibrate, you may get it so that you're hitting your make ready in 20 minutes, half an hour. As press moves out, that may go to 40 minutes, it may go to 50 minutes, then it may go to an hour. It's going to keep moving away. It's so bad that you finally realize that there's a problem. The time between realizing you have a problem and when you had the great make ready, in that time, Pressman is not going to tell you. He's going to keep matching color, and incrementally it's going to get worse and worse. So you're going to start out good, and eventually it gets worse. What we'll be doing is watching those measurements, and as they move out, we then will be correcting it and adjusting it. Instead of waiting for it just to get worse and worse over time, that time it gets worse and we notice that day after day, we correct that either on the press or through the curve. So the places that I work with, they're always watching and measuring. They compare to the benchmark. If they notice that press has got a trend where it's gone in the wrong direction, then we're going to correct it. We're going to fix that. The next thing we hear is a case study with HardingPoorman. HardingPoorman is a $28 million printer with 5 locations. They've been a G7 master printer since 2009. They have 2 G7 professionals on staff, of which Jim is one of them. And they consistently achieve less than 2 delta E color variants in their press runs. Very successful, very precise. If I list somebody who does it the way it should be done, these guys are a perfect example. Bob talks about TeshCon and how he first saw it. And as you saw in the way we looked at it before, the main thing is the instruments take all the math out of it. Easy to use, and every press minute at HardingPoorman actually has a SpectroDens. They've got a bunch of them there, one each press. So now is talk to Jim. We're going to ask him a couple of questions, and hang on 1 second. I'll get him unmuted so he can talk.
Jim, a little bit about your real test in Poorman Group. HPG HardingPoorman Group is in Indianapolis, Indiana. We're a group of interconnected companies all under one roof. We do commercial offset, wide format, variable data, and digital printing. I'm a pre-press systems manager. I have a long history in pre-press production and also the co-manager for HardingPoorman Group and all of its divisions. So I oversee the pre-press hardware, software, the file service, networking, backup and archival, and administer our Energy front end. Yeah. Okay. I've been a G7 professional for several years and actually followed Johnson for quite a while prior to G7 became a specification and had a pretty extensive history
tell us when you use G7 for performing a make ready, how do you make readies and how do you use G7?
Okay. We use G7 to calibrate our presses. We're 100% 20 micron stochastic, and we are all UV. So our make readies are critical. Our average run length is between 2,000 and 5,000. So we prep make readies all day. That's what we do. So the initial calibration of the presses and documenting densities and target densities, we have 3 to 4 plate curves for each press, and the substrate that we print determines in our MIS system which plate curve will be used. So we have known targets for each different bucket substrates, if you will, and those are in our press, and we send 3 presets to our presses from Energy. So we allow the press console to read the color bar and bring us to target densities. We use a Teshcon to measure gray balance, predominantly in the quarter and midtones, and to make adjustments for any tabs.
Yeah. Okay, well, what about troubleshooting? How do you troubleshoot a job if you can't even make ready in a timely manner?
When we do the make ready, first of all, we don't set up for very long. Our process is 15 minutes on a make ready, and if we don't have an acceptable match to prove, the pressman will stop the press and come and get me or our press room manager. We take our devices and we start troubleshooting the sheet. We use ISO check to check that the values of our primaries are what we expect them to be, and if not, how good it may be. So it will also tell us what's the best we can expect to get given the substrate we're on. As a UV printer, we print on a lot of exotic substrates and plastics and substrate cleans these. So to measure the substrate relative to the GRACOL target is critical for us. We color circle quite often to measure the reference, the G7 proof to the press sheet, and that's an ability to have an empirical go, no-go for the pressman, so that he knows to run the job or not to run this job. And we are docking, and we're not so concerned what it is, just that it's within reason between the 4 colors, that we don't have something out of control on the press.
Yeah. I talked to you the other day, Jim, that you mentioned that your pressman understand how to troubleshoot pretty much metrics. They understand lab, they understand how to troubleshoot everything using everything we're looking at there before. And they all have a SpectroDens too.
The pressman, what is, they all understand LED color. They know when they're too light, too dark. They know when to add, when to take away. They know when to do both. And specific to the Teshcon instrument, they use it. If I borrow a Teshcon from a press console, they want to know how will I have it, when will they get it back. So it's a device, an instrument that they use in every job that they print. So they do understand gray balance. They use many of the metrics in G7, but they use the devices on every job.
Yeah. And the question that people always are interested in is, how often do you have to change your plate curves? How often can you hold the print condition?
We rarely make a global change to our plate curves. We only on occasion, I have not made a job-specific plate move in probably 4 months. Again, with 3 to 4 plates for each press based on substrates, and we just will make a global change in our plate curves.
Okay. Now, how often you, or how do you compensate for different papers?
The paper difference is done when we do our G7 calibration, and we do various stocks and analyze and put them into buckets. So we have curves for coated, uncoated, matte, and then a certain bucket of plastics that we use. Using takes the substrate into account, and that really is what's made this such a valuable instrument to me in the beginning, and they got the buy-in. Trust me.
Yeah. And then just before we end, have any other final thoughts or words for the people who are listening?
It's successful, and I think the reason that part of the reason that it's so successful that we can do is process control. We measure everything. We measure our plates. We measure our chemistry. We watch the press chemistry. We measure everything we can measure, and if you measure something, it gets better. And we measure everything we can, and we try to maintain our equipment in a known state, and we know what our stake in the ground is. So when we're not hitting it, we have a lot of known values to verify.
Okay.
Jim, thanks very much for sharing all that. It's really good information. It's great to hear what people are doing in a plant as compared to a consultant who, like myself, who is teaching but not always using things in a practical situation, and appreciated it. So look, at the end of this, we have a Q&A session, but if you're watching this on the internet instead of live, you can have Q&A and you can actually ask us questions. Just email questions to Allison Lacacha, and you can see your email address there up on the screen. And we appreciate your listening to this and tuning in, and hopefully answered questions. Send an email. And if you're interested also in a trial unit or demo unit, send an email to Allison as well. Anyway, thanks for your time, and we appreciate you watching this presentation.